And I think, though, the Wood Wide Web and all the stories that go with it is an example of how science has been used to legitimize a value in a way that is inappropriate.
True, good
right?
point.
Because now it's like people, but there's evidence that trees are sending signals to each other. And it's like, well, actually, there's not. And, just at some point, it's just like, just admit you want trees to be cooperative. You want forests to be cooperative places. Okay, that's the image that you want.
But is it factual?
And you're drawing, and in this case, on misinformation to support this virtuous image of a forest that you want so badly to be because you think it's going to forward your agenda. And so to me, that's where it gets very messy.
Hey folks, what's happening? Welcome to Your Forest. My name is Matthew Christoph, and on this podcast, we talk about the environment and the science of sustainability. Today's episode is all about the Wood Wide Web. I'm sure you heard this idea, right, of the Wood Wide Web, the idea that trees can communicate under the ground through fungal networks, right? This idea has been going around for 30 years, that there's communication happening and trading resources and helping each other out. And it's changed the culture around how we understand forests, right? It's changed our ideas of how nature works. And I wanted to have someone on to talk about it because it's just such a fascinating idea. And we really want to get to the bottom of what's going on out there, right? And it just so happens that a local associate professor, Justine Karst from the University of Alberta, she's doing a study on exactly this. Her study wasn't what I was looking for, but I'm glad I found it. She studies mycorrhizal ecology at the University of Alberta, so she's made this her life. And her and a few other colleagues came across some issues that they found in the scientific literature and in the public sphere. And they decided to look into it, and what they found was troublesome. So they wrote this study called The Positive Citation Bias and Overinterpreted Results Lead to Misinformation on Common Mycorrhizal Networks in Forests. And if you don't speak science talk, that means that they found some mistakes in the scientific homework and also in the popular media that has led us to misunderstand common mycorrhizal networks or the Wood Wide Web, and Karst et al. Want to sort that out. So this story is about scientific scrutiny. It's about our relationship to nature, how we want nature to be versus how it actually is, and what happens when the momentum of an idea creates a culture, and how any resistance to that culture becomes demonized and it becomes taboo to even talk about anything other than that culture, right? And more importantly, this is a story about love and appreciation for nature, really. Like, this is where it all comes from, right? Appreciating nature as it is, what it really is, and not telling fairy tales to the public about how the world works, how forests work, right? It's beautiful as it is and doesn't need any help from us to overinterpret and over-explain what's going on. It's beautiful and incredible as it is. And that's what this story is about. And the overarching theme, I guess, is it's about the Wood Wide Web and how the idea of communicating trees became a bit of a runaway train. And Justine is like so vulnerable and open and honest in this conversation. I couldn't have asked for somebody better to explain where she was coming from when she did this and what she hoped to accomplish. Anyways, I'll let you listen to it. You can decide what you think. Sponsors for this episode: West Fraser is the number one sponsor for 2023. Without them, this would not be possible. Thank you, West Fraser. And finally, Greenlink Forestry has been with me since the beginning, and I could not do this without them. So thank you, Greenlink. And that's it. Let's talk Wood Wide Web and love of forests. Here we go. Okay. What brought you to this work? How did you end up doing this?
I would say, probably like most people, it started when I was a kid, and I grew up in the bush, and so we lived about 30 minutes outside of Nelson in interior British Columbia, and so my childhood was spent out in the forest, and like most kids, super curious, and I loved taking things apart, like rocks. I like to smash rocks, dig in the soil, see roots, and even gross stuff too. It's like if there's a little carcass of some animal, I'd like to, dissect it. I saw it as an opportunity of like, what's inside?
Oh yeah.
So always very curious. And then too, it's like growing up, living in the forest was great. I loved it. I loved all the memories. But there was also parts of it too that made me just wonder, I guess, about the future of forests, our relationship with that. And like for an example is, there was one time and we were evacuated because there was a wildfire on the mountain next to us. And so then it was like, this forest playground, but then it was like this totally scary place. And I'm sure there's many of your listeners that have now had experiences with fires and kind of close calls. So that, and I think too, it's just that relationship. So for example, when I was a kid, my dad, he worked at the local sawmill. The sawmill closed and then he was laid off. And then we had to leave the forest. We had to leave that place. And, so my dad could get a job somewhere else. So there was kind of, a lot of layers, I guess, to my experience in forests. And then fast forward to probably, I guess, when I was an undergrad, did ecology. I was always, really drawn to ecology. And then in my master's, I was doing forest ecology. And at that time, a paper came out. It was 1997, and it was a Nature paper, and it was this experiment showing below ground carbon transfer between trees of different species. And it seemed like it could have been through this mycorrhizal fungal network. And that just blew me away. I just thought that was so fascinating and so much potentially going on below ground that I wanted to learn about.
Yeah.
And so it was really that paper that just got me so hooked.
Wow.
Yeah.
Okay.
And then
so deep roots to this conversation.
Oh,
then.
Yeah. And then one of the co-authors of that study, Melanie Jones, then I contacted her and then, pretty much begged her if I could please do graduate studies with her. And because I really wanted to study mycorrhizal fungi in forests. I just thought there was just so many captivating things about it. You couldn't really see them. People didn't really know very much about them. They might have huge effects on trees and interactions. And so, yeah. And I guess I've never looked back since.
Wow. Okay. I didn't realize that it was that deep.
Yeah.
So it's been decades long exploration, right? Like it's
it's been I think just over 20 years. Yeah.
So this is deep seated in your mind and something you've been thinking about for a long time. Yeah.
Yes.
Absolutely.
Yes, definitely. Yeah.
So I imagine at the time, maybe you can paint the picture societally, the impact that paper had on these conversations for people, just so they could bring them back to know like how that changed things.
Yeah. It was, it was controversial for sure. So in the research community,
this is the Wood Wide Web.
This is this is the paper that got coined as the Wood Wide Web.
Right.
And so in the paper, it describes the experiment. They explain, they demonstrate there's some below ground transfer of carbon, probably through a mycorrhizal network, not necessarily conclusive. And what happened though is that I think it was more the way that other people interpreted that paper that became very controversial. So there was a lot of focus on the methods and the techniques, and were they actually showing carbon transfer? Were they actually showing that carbon ended up in the tree seedling? So there's a lot of focus on that, critique on the methods. And then there was sort of this other camp of just like, this is transformed ecology. Because now, before we used to always think that trees compete with one another. And now it looks like resources are equalized across all trees in the forest. And, and that was a pretty radical idea for that time.
Totally.
And so, and I think people really got interested in that and really kind of ran with it. And, that paper didn't show that. It showed that there was this little amount of carbon moving below ground, maybe through a fungal network, but there was no evidence that it was affecting, say, the seedling performance, growth, or survival. So there was a lot of sort of conjecture, I think, of what those results meant in the wider community. And so that caused lots of discussions, as it should. It was a very disruptive paper.
Right.
And
which is always exciting.
It is. Yeah. No, it was a very exciting. And like I said, I mean, that's what got me into mycorrhizal
you're
ecology,
because of that,
was that paper.
Yeah.
And so then following that, there were some more field experiments, some more lab experiments to try to kind of pin this all down a little bit more. And then it kind of fizzled out. And then I would say in the past 5 years, it's just like taken off again. And it's not necessarily that there's been a flurry of experiments to change that evidence. It's just the ideas have like resurged and just, like blown up in the public. Yeah. And that's kind of where we are now, I think.
Gotcha. So before we go any further, I think we should slow down and actually just explain what we're talking about, these mycorrhizal networks. Or how did you say them? You said,
people call them different things. So I call them Common Mycorrhizal Networks.
Okay.
But you will also hear it called the Wood Wide Web. The Wood Wide Web kind of means something a little bit differently.
Okay.
Some people will shortcut it, fungal networks. The word fungal networks is used in all sorts of different ways. But when I talk about it today on the show, what I'm talking about is when roots of two different individual plants are physically connected below ground by fungal tissue.
Okay.
So there's a physical connection between two different individuals. They could be different species, whatever it is, but they're physically connected. And then I would call that a common mycorrhizal network.
Okay. Gotcha. So, well, first of all, we should talk about what these common mycorrhizal networks are. I don't know how you want to do it. Hypothesized to be, or why those mycorrhizal networks would form in such a way. And also, I think we need to paint a picture. I'm just trying to paint a picture in people's minds about what we're talking about before we get into the your study. And also the breadth and, the size of these networks, right? How common are they and that kind of thing. And I know these are all they're all up in the air kind of thing, but, so let's start with just, what can we definitively say these mycorrhizal networks are?
I think we can definitively say, so in the lab, we've seen them form, like between tree seedlings.
Okay.
And I should also say, so everything I talk about is going to be trees or tree seedlings. There is a very wide literature that includes plants of different mycorrhizal type, like the forbs, herbs, grasses.
Sure.
I have not looked very closely at that literature, so I can't speak to that.
So
I am just focusing on
trees. Okay.
Trees and tree seedlings, like the trees that make up a forest. So we know in the lab that these mycorrhizal networks can form. So very nice studies showing the fungal links between roots of two different seedlings. In the forest, it's quite different. And so we rely on kind of indirect techniques to piece together what we think the common mycorrhizal network is.
Okay.
Because of course, as soon as you start digging in the soil and you start looking for the fungi, you destroy the network. Right. It's all like you tear it up. Yeah, it's delicate and you just tear it up. So we can't really...
To paint a picture, if you're in the bush and you just like dig a shovel in the ground and lift it up, it's those like white kind of strands, those long white strands. That's what we're talking about. Is that it? Yeah. Okay.
Yes. Yeah. Yeah. So you'll see fungal mycelium in the soil. Some of it might be mycorrhizal in that it's connected to roots.
Oh, okay.
A lot of it's going to be saproptrophic, like the decomposer fungi.
I see.
It's all going to be mixed in there.
But my point is it's very delicate. Yes. It just like breaks up easy. It's not,
Oh yeah. If you put a shovel to it, it's going to break.
Yeah.
So we've only found one case where, that there was his name is Jim Trappy, that he went out and then he actually did find a thread of fungus that was quite robust. It forms this particular structure and then followed it back to some tree roots.
Oh, nice.
But like, no one ever does that. It's like a very unique case.
Gotcha.
So most of the time we're using indirect methods.
Okay.
And that looks like where we, find, say, colonized roots. So colonized being they have a mycorrhizal, a fungal sheath around them. And we can then genotype the roots of the tree and genotype the stems to know which individual tree that root belongs to. So this would all say it's Douglas fir. That's like one forest where this has been done quite a bit. So they know which individual stem, Douglas fir, this root belongs to. And then some mycorrhizal fungi form very distinct structures. So you can look at it and be like, okay, this is a rhizopogon because it forms this like potato-like structure. Yeah. So you can visually find them. And when you see them, then you can genotype that potato-like structure and then figure out, okay, so I'm seeing this particular genotype colonizing this root. And when I go over here, I'm seeing the same genotype.
Okay.
And so then we assume if we're seeing the same genotype in two places, that could be a connection.
That they're relatively close together. Yeah.
Yeah.
Okay.
But of course, when that identical genotype is further and further away, then naturally it's like, well, is that actually a continuous connection? Right. Because that's like 10 meters away.
Right.
Chances are it's been grazed, it's been broken. Like the further away it is, the more likely it's been disrupted. Okay. So it's actually when we take very, very small slices of the soil, like 10, 20, 30, 40 centimeters, that kind of thing. And if you find the same fungal genotype, then we are more confident that this is probably a link.
Okay.
Okay. But that's been done twice in the world.
Only twice.
There's only 2 studies that have done that high resolution sampling to give us quite a bit of confidence that, this root and this root over here are linked by the same genet of fungus.
Gotcha.
So one has been in a Douglas fir forest and another one has been in a Japanese pine forest, but that's it. So, and then you think about all the forests out there in the world.
Right.
Like our mapping is so minimal. So even that basic question, how widespread are mycorrhizal networks? I don't know.
Right.
We don't know.
Right.
There's lots of reason to think that tree roots in forests are probably connected by fungi. Like that mycorrhizal fungi is everywhere in the soil.
Totally, right.
It's very likely, but we don't know how long those connections are. And really importantly, we don't know how long they persist. How long does that connection last? If it's not there very long, then it's likely not to be that important in moving around resources. If it's there for a really long time, persistent, and, at the distance that it's been able to connect 2 different trees,
right?
Then maybe then we are more, then it's more convincing that maybe they're doing something about, moving resources below ground.
Gotcha. Okay.
Gotcha. Yeah. And I mean, of the general mapping, so there's 5 studies that include mapping the mycorrhizal network. 2 of those are done at a very fine scale spatial resolution that gives us confidence that those links actually happen.
Oh, I see. Okay.
Yeah. Yeah. But still, there's like over 70,000 tree species in the world.
Right.
We have 2 tree species that we've looked at.
Yeah.
Yeah.
So there's only a few studies really done to support all the information that's out there about the so-called Wood Wide Web.
For the mapping anyways.
For the mapping portion of it, yeah. Okay. So we don't really know how big they are, how common they are, but we can conjecture that probably they're there. They're there.
Yeah.
Right.
I think we're on safe ground to say they're probably there.
It's just what is their role? We don't really know.
What is their function? What are they doing? What is their role in the forest? And I want to be clear that there's no dispute that mycorrhizal fungi are important in forests. there's so many experiments showing that they are important in forests. And we now know a lot more too about their role in like forming soils, sequestering carbon, like all of that. There's no dispute about that.
Okay.
What is, I guess what is unknown and not settled is the function of these common mycorrhizal networks.
Okay.
That's a really important point.
Yeah. So we know that they're important. They have to exist, and it's good that they exist, and they do important things. But we don't know the extent of those important things. And there's been a lot of the reason we're here today. And actually, it's funny. The reason that you're here today is I've been trying to find someone to talk about these networks for probably a couple of years now.
Oh, wow.
And just haven't been able to find anybody that's willing to go into it in depth and was available, right?
Yeah.
And one of your, I'm assuming one of your students
Serena. Yeah.
So she reached out, and so thanks, Serena, and mentioned your name, and then we got to talking, and I wasn't planning to have this conversation with you, but based off the study that's coming out, I'm excited to get into it because it definitely changes the way you imagine these networks. So, without teasing it any further, let's get into your study and how did this study come about? So why did you think this study was important to do, and what was your concern?
Yeah. Okay. So the reason the study happened was, I guess it was November. Just the years are kind of a mess because of COVID.
Mm-hmm.
Not this.
Tell me about it.
Yeah. Not this past November, the November previous.
Okay. 2021.
Okay. Thank you. Okay. So, I was invited to interview for, a documentary by NHK, which is a Japanese, broadcaster, and about mycorrhizal networks in forests. And so, of course I was excited about that. And they sent me, not like a script as in like, here's what you're going to say, but just, just like kind of a suggested outline and things that they wanted to cover.
Right.
And some of the topics I was really surprised by in terms of what they wanted to talk about. Cause I looked at it and I thought, holy cow, like there must be a whole bunch of new studies out because I just don't remember these. Like
right.
I just don't recall studies supporting this kind of stuff.
Can you give us an example of what kind of stuff they were?
So
just to put the feelers out there for the kind of conjecture that's out there. Yeah.
Yeah. So trees sending warning signals to each other of, insect attacks, different tree species, moving carbon in one season to the one species. And then, in the other, like in the fall, then the carbon moves to the other species all through mycorrhizal networks. And I just didn't remember reading anything about that.
Okay, yeah.
But of course, right away I was like, oh boy, I got to go back to the literature because obviously like I'm missing some big papers here. So that was my immediate thought. Like I am way behind this field. And so
kind of an existential threat moment. You're like, wait, am I a terrible scientist?
Well, that's like, I was just like, oh my God, Justine, you're so behind in the literature, which is like always the case. But then I called up Melanie Jones. So Melanie was my former PhD advisor, and she's often the one that I go to for like kind of touching, like when I need to hear about sort of classic ideas in mycorrhizal ecology.
Yeah.
She knows all of that. She's been around for a long time. And so then I asked her, I was like, Melanie, am I missing some stuff here? Like, I feel like I'm missing a bunch of studies.
Yeah.
And then she's like, well, I don't know. And then we started talking about it a little bit more. And then we started talking about the studies that we were aware of and then thinking, did they really show that? But we hadn't really dug very deep.
Sure.
It was just kind of you're working off your memory. And then Melanie mentioned, one study that she was on and she said, often that study, it gets miscited. They say it's evidence for this, but, for example, carbon transfer through mycorrhizal networks, but that's not really what we showed. Mm-hmm. And then I asked, well, do you think that's a problem? Just that some of these studies, maybe they're just being cited incorrectly?
Sure.
And then she said, oh, maybe. And I said, well, maybe we should look into it. And then the other thing is it had been 25 years since that Nature paper that Melanie was on.
Right.
Melanie's close to retirement. And I said, Melanie, this would be such a great thing to revisit before you retire.
Yeah.
And she said, okay, let me think about it. So that's sort of the start of it. And then shortly after, Jason Hoeksma, he contacted me, and I think he had already done a seminar for some group about, he was already ahead of looking at or paying attention to the ideas out in the public. And I had not been paying attention at all. And then he's like, have you heard some of these ideas? And I said, well, I saw this script. And so I was wondering, I'm like, I don't know where these things are coming from. Like, I was a little bit confused, but and so he was much more ahead. He's like, oh, you should look at this. Like, very little, short videos and things like that.
You should watch Avatar as well.
Right. And so he was already kind of in there. And then we talked, okay, let's work together on this. And so that's how it started.
Okay.
Yeah.
So that's only 2 years ago then. So like not even. Year and a half ago.
It was not that long ago. But on the other hand though, it's like you have to remember, so the three of us, I mean, Melanie spent, she's retiring soon. Her whole career since she was like a graduate student has been in mycorrhizal ecology. Jason and I are the same, as graduate students, always worked in mycorrhizal ecology. So yes, the paper only started about 2 years ago, but we each have like our whole careers working on this.
No, for sure.
So it's like, it's not like, we're coming into the field as strangers. This
took you by surprise too. It took all of you by surprise, and just kind of like all of a sudden you're like this. How did this like shatter your view of what was going on?
No, not yet.
Okay.
Not yet. I was still open to like, I don't know, like let's have a look. Because maybe we're missing some stuff.
Sure.
And so what we did is Jason and I spent some time, Melanie wasn't so interested in doing this part. And I don't blame her. Like looking at the popular media, she was like, no.
No, thank you.
No, thank you.
I don't want to get a Facebook account.
She's like, no. But Jason and I we spent a lot of time, reading, watching videos, podcasts, the works, right? And there's so much out there. That was sort of surprise number one, was like how much was out there. And then from, it took us, I don't know, we're probably talking like over hundreds of hours of just immersed in the public idea of the Wood Wide Web. And then we came out, we kind of extracted what we thought were the three most common claims out there. So one of them, and we've touched on this idea that common mycorrhizal networks are widespread in forests, all over the world.
We've touched that now.
Okay, we've touched, so we kind of, we already know, like, okay, we think that they are, but we don't actually know.
What's the total area? Do you have like a total area percent, or like, you know what I mean? Like the entire world is a big place. You said only 5 studies did this mapping. And
I did calculate that. So when you add up the total area across those 5 studies that have been mapped, it's about a hectare.
Oh, and so that's the whole world.
And so I don't know how many, there's like 4 billion hectares of forest.
I don't even know.
It's
a lot more than one.
Oh yes, and by no means
not to say you need to do everything.
No,
but
exactly. It's like I would never suggest we even have to look at 1 billion hectares, but like 1 hectare, I don't think that's enough.
And probably to say around the world, you probably need to check out at least all of the different major
forests.
Types of forests.
Yeah, absolutely.
And right now we've only really checked out basically
2. Yeah.
What's
Douglas
that?
fir.
Yeah.
Interior Douglas fir, and then this Japanese pine forest. That's it.
So that's a big jump.
Yeah.
Gotcha.
So, actually, that's with the mapping. I want to clarify. So the mapping has just been done in 2 studies, but the field experiments have done more in a range of forest ecosystems. But so that was the first claim that we extracted. The second one is this idea that seedlings benefit by being connected to trees through a mycorrhizal network.
Okay.
And then the third one was that big old trees recognize their kin and send warning signals to their kin through common mycorrhizal networks.
Okay.
So those are the 3 that we felt like just over and over and over that we were seeing.
Those are the ones that the public's holding on to.
Yeah. Or at least like communicated very widely.
Sure.
And so that's what we started with. We're like, okay, let's evaluate these claims and see what we find. So the first one, so I told you about that one so we don't know very much, and very few studies have been mapped, or very few studies have mapped common mycorrhizal networks.
And that's not to say that they might not be worldwide, but
definitely. And like I said, there's lots of reasons to think that trees would be connected through these fungal links, but it's just sort of putting the brakes on though, that like, we don't know for sure.
Let's not get ahead of ourselves here.
We want to do some more mapping. We would want to do some more checking around to like just feel more confident in that claim.
Right.
So there's that one. So then the second one, so this idea that seedlings benefit from being connected to other trees through this common mycorrhizal network. So there we looked for all the field experiments we could find done in forests or like plantations, something like that. Trees basically out in the field.
Yeah.
And so the first thing, so there's not that many. I think that there was about like 25. There's not that many field studies. They are scattered and they're more representative of different forest types than the mapping networks though. So that was good. So there's some temperate forests. There's a couple studies done in more tropical areas, things like that, which is all great.
That's not a bad number for something that's only been a topic for 20 years or 30 years. I guess that's a pretty good number of studies, but yeah.
It's not bad. Yeah. I mean, you always want to see more, but and then we drill down to each of those studies. And often the way that we manipulate mycorrhizal networks in the field, there's a few different ways, but many of the studies, they will plant seedlings into these mesh bags. And the mesh bags, they differ in pore size. So when it's a really, really tiny pore size, fungal hyphae can't get in and roots can't get into the bag. So the seedling would just be growing in soil, absent any connections or interactions with surrounding roots. Then there'll be another treatment where the pore size is a little bit bigger so the fungal hyphae can go through. So potentially the seedlings would be able to access a common mycorrhizal network. And then a third treatment where roots and mycorrhizal fungi can interact with that seedling. There's some other variations of that where we're trying to manipulate access to mycorrhizal networks. But that's sort of the overview.
Okay.
But with those experiments, and I want to be clear, I mean, many of these experiments were the best for its time. It's this is the best we could think of. I've done experiments using this technique. It's a tricky thing to do out in the field. So by no means am I poo-pooing anybody's experiment. But of course, as the field matures, as we look back to these experiments, we can see, there's some confounding effects. So there's these confounding effects that don't...
Can you explain what a confounding effect is?
Oh, yeah. So that would be when we're setting up an experiment. Say you have a treatment and it's isolating some mechanism.
Okay.
So, in our case, we're trying to isolate the effects of access to common mycorrhizal networks. But a confounding effect is an inadvertent, intentional, another treatment that you have applied that is confounded with the treatment of interest. So we are interested in isolating mycorrhizal effects, but by isolating and manipulating common mycorrhizal networks, at the same time, we have inadvertently caused these other changes.
Oh, I see. Okay.
Right?
Okay.
So it's like, the seedling...
It's not the only thing you changed, just the thing you're measuring. You've changed more than that.
And it's unintentional. Yeah. And sometimes you don't see it when you're setting up the experiment.
Yeah.
Like you don't know, oh my God, it's confounded with all these other things happening.
Yeah.
And sometimes it's only hindsight that you can see, or unfortunately for most of us, someone else points it out to you during review. And you're like, okay. So that particular kind of treatment, so there's confounding effects. So when you look at the results, you don't know. So is the seedling responding to a difference in access to mycorrhizal networks, or is it responding to one of these confounding effects that I haven't measured and are also changing at the same time?
Gotcha.
So there's nothing necessarily very conclusive. So that was one thing that we noticed or recognized with these experiments. But even if you ignored the possibility of confounding effects and just looked at how seedlings responded to the presumed treatments, like let's pretend our experiments, there were no confounding effects. We were able to isolate and manipulate access to mycorrhizal networks.
Okay.
We found that only 18% of the experiments, the seedlings actually responded positively to access to mycorrhizal networks.
Oh, wow.
So the other portion of seedlings, most of them have no effect.
Really?
It didn't matter if they had access or not. It was neutral. So it's only a small fraction of studies that are showing that seedlings might have positive effects from access to these mycorrhizal networks. And again, that's if you ignore all the confounding effects, which I would argue you can't.
Yeah.
So
this is science after all. You do want to be objective. Yeah.
So that was surprising and a little bit, I guess in my mind, I didn't think it would be, I thought there were more studies that actually showed positive effects. I thought that was a little clearer. And then when we sat down and really scrutinized those studies, it was surprising. It was like, okay, no, the evidence is not nearly as strong as we thought for seedlings benefiting from these common mycorrhizal networks.
How did that feel when you guys started to come to this conclusion, and especially for someone like Melanie, who was part of that original paper and that kind of thing? So
yeah, I think there we were a little like, ooh, okay, that's sort of interesting. And then I think when we moved on then to looking at this idea, which was under this claim, was that the reason that seedlings benefit is because resources are transferred to them. And then, so again, we looked at field studies, and then there is no conclusive evidence
really
that resources are being moved through these networks.
Because it could be something,
it could be moving through the soil.
Oh.
And so with the experiments, like there's different ways of assessing how resources are transferred.
Right.
So one way they do it is say they have two seedlings of the same mycorrhizal type, say ectomycorrhizal.
Yeah.
And then one seedling that forms a different mycorrhizal type, arbuscular mycorrhizas, for example. Ectomycorrhizal fungi and arbuscular mycorrhizal fungi, they can't fuse.
Okay.
There's no way that they can form a common mycorrhizal network.
Okay.
So when you label an ectomycorrhizal tree seedling with, say, some carbon, and then trace it, and if you see that, okay, it ended up in the other ectomycorrhizal seedling, but none of it ended up in my arbuscular mycorrhizal seedling, okay, that's pretty strong evidence that it's moving through a mycorrhizal network. And it is. Yeah. Again, like that was a really novel way to be addressing this question of resource transfer. But the problem is that these two types of fungi, arbuscular and ectomycorrhizal fungi, they're very morphologically different.
Okay.
So the ectomycorrhizal fungi, they put out a lot of hyphae, they're really dense in the soil. The arbuscular mycorrhizal fungi, not so much. So even if there was no connection between the seedlings, if you dropped a resource in the soil, the ectomycorrhizal fungi are going to pick up and acquire a lot more of it than this little arbuscular mycorrhizal fungi. So using this arbuscular mycorrhizal fungi fungal host, it potentially underestimates how much might be moving through the soil.
I see.
So it's not a fatal flaw. It's
right.
just something to kind of keep in mind. And as with the other field experiments, hardly anyone actually documents that the seedlings are connected by fungi, these fungal networks. It's always assumed
that they're there,
but they are hardly ever checked.
Right.
So we don't know. And then the other thing with the resource transfer is, okay, so again, there's this confounding effect of differences in mycorrhizal type. In some field experiments, they don't use that control. They don't have a different mycorrhizal type, like a seedling of a different mycorrhizal type, to control for how much might be moving through the soil.
Oh, okay.
So that's missing in some experiments. And then in some field experiments where they do use, say, the mesh bags, and they eliminate mycorrhizal networks from forming between trees, seedlings, or whatever else.
Yeah.
There are studies showing that there's still carbon moving.
Oh, really?
So
we know there's other things that are doing this, not just mycorrhizal networks.
Definitely. We know that like root exudates or something.
Right.
There's some way that this carbon is moving below ground that is totally independent of mycorrhizal networks.
Interesting.
So that was eye-opening. And then I think for us, we were starting to feel a little bit like, that's I think when we got the sense of like, okay, the evidence is not as strong as how it's told out there in the public.
The popular media is
but
really...
also in the research community.
Oh, really? Okay.
Yeah. And so, I mean, I'll get to that. So, okay. So now we're a little bit sad. Okay. But not like totally sad yet, but a little bit sad.
Yeah.
And then we got to this third claim that big old trees can recognize their kin and send warning signals to their seedlings through mycorrhizal networks.
Warning signals because of pests or
yeah,
something.
Like say the tree has been attacked by insects, it mounts its defenses, and then there's a signal that runs through the mycorrhizal network that would warn seedlings connected to that network.
Yeah.
Yes, exactly.
Yeah.
So yeah, exactly. Protect yourself.
Yeah.
There's a drought coming. There's insects.
Okay.
So, and I mean, and that one is very tantalizing and just like, wow.
Like, wow, they're watching out for one another.
Yeah, like, wow. And
or I should say the fungi is watching out for them. Yeah.
Yes,
yeah.
right. Yeah.
I guess that's another big one. We'll get to that.
Yeah. The fungi are looking after the trees. So that one, and there's just the public, there's just so much traction with this one in the public. So then we searched, where is this idea coming from? And what we found is it seems to be based on a single greenhouse study where two seedlings, ponderosa pine and Douglas fir, were grown together in pots. The Douglas fir was either left alone, or I think it was spruce budworm applied on the needles, or like chopped up.
Okay.
And then measured defense activity in that seedling. And then they manipulated whether the seedlings were connected through mycorrhizal fungal networks or root interactions using the mesh bags, and then measured the defense activity in the receiver seedling.
Okay.
Okay. And so what they found is, so when Douglas fir, insects, chop needles, it mounts a defense as you would expect.
Right.
And then in the treatment where there's just fungal connections, the ponderosa pine then, so it mounted its defenses as well.
Okay.
So when they're connected through fungal networks, we see that the seedling mounts its defense as well, which is really intriguing and cool.
That's cool. Yeah.
Yes. But the other part of that experiment, though, is in the treatment where the neighboring roots are allowed to interact, which is the case in in like you cannot find a common mycorrhizal network, in absence of roots. Like right? Like they go together.
Right.
So that last treatment where the roots between the two seedlings were allowed to interact, there was no, the receiver seedling, its defenses were not mounted. It's like the presence of neighboring roots and allowing them to interaction totally canceled the response, this defense signaling.
So what the hell does that mean?
So I would say, I mean, that's kind of the closest we have to what actually happens in a forest.
Right.
Roots in common mycorrhizal networks, they interact. Fungi might be connecting seedlings, but there's all these roots there too.
Mm-hmm.
And to me, that says, okay, I mean, there was a positive, I guess, but it was totally canceled out by the presence of roots.
Okay.
So I mean, so to me, I'm like, I don't really know what that says. Does it say anything? Because that is the normal condition in forests, roots and fungi.
So we're kind of unsure. Like it's not really,
Yeah. And so, I mean, and the most important point is, so this is also a greenhouse experiment.
Mm-hmm.
Like we cannot, in my opinion, it's irresponsible to extrapolate outcomes of a greenhouse experiment to forests,
right?
To mature trees, seedlings in a forest. Like they're so different.
Mm-hmm.
And, it's the same thing. It's like when you're doing studies on cancer and you're doing it on little cell lines and plates.
Mm-hmm.
And if you have a result, you don't say, okay, I found the cure to cancer.
Yeah.
Like now we're going to, like, this is how humans respond to it. It's like, no, there's so many steps in between to get to that point.
Mm-hmm.
And like those steps are missing.
Yeah.
So the other thing that we found, though, so there was just this one greenhouse experiment that, intriguing, some interesting results, but in my opinion, should not be like applied to a forest.
Right.
And then the other thing, so then we started looking at theses as well. So these are not peer reviewed, published as theses.
Mm-hmm.
And so some of them, so again, we could not find any support. There was two that they did do some field work, some field studies, so which was great to see all this move out to the field. So one study didn't find support. And then the other study, it's like the results were actually counter to this idea that, seedlings that are kin with the adult tree, through mycorrhizal networks grow better. And in this case, they found that actually kin did worse beside kins.
Really? Okay.
And mycorrhizal networks had nothing to do with it. They had no role in it. So that, I think when we came across that claim, evaluating the evidence for it, I think all of us were pretty sad.
Right.
And just like, what has happened to our field? And,
you spent the last, your entire career was this.
It's just like, what does this all mean? And, you hear how the public talks about the Wood Wide Web, and you realize it's like, these are really unfounded claims. And so
it was probably exciting before, thinking about like, look at how much support we have for this research and for doing this. And this is exciting. This is transforming the way we think about forests and transforming the way we do management and transforming our ideas of what, life is and coexistence. And then you come across this and
it honestly felt like kind of a house of cards.
Yeah, totally.
It just like when you stepped back and looked for the actual support for these claims, and none of them have strong support, yet those are the ones that everybody's talking about. It was kind of shattering, to be honest. Like, and partly, through my career, it's not like I had all these claims in my mind. I mean, I knew that there was debate. Again, like kind of the last claims I didn't, the one about the defense signalings that I hadn't even heard of really. And so it was pretty shattering. But I think though, so Jason, Melanie, and I, we always had in the back of our mind, like, okay, these are the field studies. We all know how difficult it is to do field studies. And like, are we that surprised that they're not as clear as what we initially thought or what we would like? Not really. They're field studies. Yeah. So we always had this thing in our mind that like the lab studies were our gold standards. Right. And like we could always go back to the lab studies because they will show the story. And then through review, the reviewers asked us, because initially we just focused on the field studies and what they said. And the reviewers said, you need to go back and look at the lab studies. And we were kind of like, why? What do they have to do with forests? And they're just like, it's remiss to like ignore this other piece of evidence from lab studies.
Right.
Okay, fine. And we were like, we already know what these are going to say. They're going to say like, they're going to be supporting these claims. And then when we went back and looked at the lab studies, there was a number of confounding effects in lab studies that when it all came down to it, again, this is just with tree seedlings. Yeah. There are like 3 lab studies showing carbon transfer through mycorrhizal networks.
Which is very cool.
Yeah. And totally. And only one of them that shows that the carbon actually moved up into the plant and didn't stay in the fungus.
Oh, okay.
But the other studies about, water, carbon, nitrogen, they just didn't hold up to scrutiny. They have confounding effects. And so you cannot conclude that resources are moving because you have to rule out these other confounding effects. So I guess when we went to the lab studies, and I just remember we had a meeting and we were just all like, oh.
Now what? Yeah.
Now what? Like, what's left? Like, it was really, I mean, I don't want to say I went into a depression because that's like a really strong word, but I would say for sure that I was like grieving and in despair and frustrated and shocked and confused in like, how did this happen? How did we get here?
Right.
And and
you're the people who, this is your life. This is like, you're the ones who would know this, right?
Yeah.
And so like, if you didn't know this, then nobody else does. Like, yeah.
And so then the second part of the study though, so we evaluated those claims, but the second part of the study, we wanted to try to understand how researchers were thinking about these ideas.
I think that's important because I think I can think of multiple examples in my mind where the media has taken a scientific paper and jumped to wild, crazy conclusions, and the popular culture is taken off with it.
Yeah.
And like it happens all the time, right? It's just like that clickbait stuff, right? Like the one example that comes to mind is that I probably shouldn't even say it because I remember there was conflict around it, but it was something about meat causing cancer, right? And it turned out that the paper was saying that nitrites cause cancer, and there's nitrites in cured meat, right? So they just jumped to the conclusion that, well, meat causes cancer. You shouldn't eat meat. It's a carcinogen. It's like, well, no, that's definitely not what, but it just like, it's popular and it takes off. And in certain communities, love
Yeah.
it, right? And it tells their story and helps further their cause. So we know that the media does that.
Yeah.
I feel like that's not a surprise.
No,
right?
exactly. It's like,
Yeah.
you know, and
they're not really equipped with the tools to really tell that story properly anyway. So I wouldn't even blame them so much as I would just say that that's a microcosm of
larger
not
issues.
Understanding science.
Yeah, like science communication and stuff.
Exactly.
For sure. And I was, the same thinking. And then, so the second part of the study then is, so we wanted to try to figure out, so how are researchers thinking and interpreting these ideas about common mycorrhizal networks in forests and their function?
Did you guys study your own work?
Oh, we did. Yes. So I should say in the first part.
Did that further your grieving?
It did. It was hard. Like, so Melanie's done experiments. We've all done separate experiments on common mycorrhizal networks in forests. And in the first part, when we were looking at the possible confounding effects, for all of us, confounding effects in all our experiments. And it was just like, oh, I wish I could go back and kind of rewrite that discussion. Like I wasn't thinking, I wasn't aware. But
you don't know what you don't know.
No.
Right?
So, I mean, it is what it is and it's done. But yeah. Okay. So then for the second part, we identified, I think it was 18 studies in total. So we searched for studies on common mycorrhizal networks in forests that we considered highly influential. So these are field studies and they had at least 50 citations on Web of Science. And so we called those like influential.
Right.
And then what we did is we looked at all the citations of those papers. So there was about, I don't have the exact numbers. I want to say about 2,000 papers in total that we looked at to see how they cited those original studies. So some of the original studies, they, in their discussions, they were really clear about, well, it could be this, it could be that, the caveats.
Yeah.
Some studies, like one of mine, just didn't even recognize, there's these confounding effects. So it wouldn't have been in the discussion.
Right.
But we looked to see how newer papers then are citing these original studies. And then we looked at each of the citation, like looked at the statement and then put it into a category of either supported or unsupported. And then did that for like these 2,000 papers. And then we looked at the percent of unsupported citations or statements over time. And we found that it's increasing. So we had it divided into two sets of papers, one that focused on common mycorrhizal network function and then structure. These are like the mapping studies and stuff. And so for the papers, the original studies on function, initially the unsupported citations or statements was about 25% of papers were making unsupported statements, which is already a little bit high. So that was way back 25 years ago. And now fast forward to today and we're up to nearly 50%. So 50% of the papers that are citing these original papers are making unsupported statements.
Ugh.
Yeah. So that is a pretty high number.
That's one thing when it's in media, but when it's in
this
science.
is in the scientific literature.
Yeah.
And then of course it's
and
like
going unchecked as well.
Yes.
Unnoticed. Yeah.
Yes. And then when you look at kind of the nature of the unsupported statements, it's things like, for example, say one of the mapping studies, somebody would cite that mapping study as evidence for carbon transfer. And it's like, no, that paper, that study never looked at carbon transfer. They mapped to the mycorrhizal network, not just because it's like a ton of work. So they are over-interpreting. Well, in that case, I mean, it's almost fabricating. It's like, no, the study never looked at carbon transfer. You cannot cite it for evidence as carbon transfer in a forest because that's not what they looked at. And then, and there will be other examples like, seedlings benefit from common mycorrhizal networks. And then they'll cite a certain study that didn't show that.
Yeah.
Or that there was these confounding effects that like, no, it could be these other things.
Right.
So those are examples of the kinds of unsupported statements. But what that means though, so again, I mean, you mentioned this, it's very easy to point to the popular media and like, oh, look at you guys. You don't know how to communicate and you're telling all these stories.
Yeah.
But whether it's intentional or not, we scientists have become vectors for these unsubstantiated claims as well. And we, as in I have some papers that were on the naughty list. Like Jason did, Melanie did. We all did. And at first you were like, oh, it's so benign. You know, it's just like one miscitation. It's not a big deal. But when you look across papers and it's this cumulative growth over time to now we're at the point, it's like, is the public feeding us this narrative or are we feeding the narrative to the public?
Everyone's just got excited. Like this idea came out and everyone, what? Are you serious? Is this what's going on? Is it all like cooperation and very little competition out there in the forest? And everyone just like, I think it brought in our hearts into this idea, right? Like even to science, it just brought in that emotion. It brought in that this is so exciting. Let's do this. And then we kind of got wrapped up in the excitement on, you know, everybody did. And it just kind of snowballed into something where now it's got this momentum and it's like, well, how do we?
I don't know. Yeah. How do you put this genie back in the bottle? I have no idea at this point. Like, you know, I mean, I'm on Twitter and every single day there's tweets coming out about the wood wide web.
I noticed you're pretty active. Yeah.
Oh yeah. About trees warning each other of insect attack. Like every single day there is stuff coming out. Like I don't know. And again, it just seems to tap into this, like, we love this idea that trees are cooperating with one another through these benevolent fungi. It's just it's so appealing and cozy. And I guess part of it too, it's like, I kind of wonder, like, why now?
Yeah.
I mean, these experiments, some of them were done like 20 years ago.
Right.
Like most of them are not new experiments. These are experiments from the past that people have like latched onto. And I don't know. And I've had some colleagues, you know, from humanities kind of weigh in and think about it, but I don't know.
It's tough.
Yeah.
No, I think like our culture in general, Western culture, has been moving away from the idea of, you know, the colonial kind of capitalist mindset. We're trying to move ourselves into a space of balance and cooperation and kind of thinking about all the factors and not just ourselves. And so this makes sense that this kind of came out and followed along with that. And we were all excited about it, and it's moving that direction.
But I think too, it's also an example of like, we're looking to nature for how societies should behave or act, or
as a model.
As a model. And so we're looking to nature because nature is nature.
Yeah.
And surely nature is the only and best way. Yeah. And I think this is a very clear example of just like why that doesn't always work. Like, if we want to change our societies, if we want to manage forests different, these are all really great questions, and include different ways of knowing. These are all great discussions. But it's like we, the people, can decide what we want to see. And in this case, I think, it's like people,
cherry-picking,
it's like we're looking to nature to tell us how to live. But in this case, the science was not there.
Which is fascinating that it's been so blown out of proportion and gone so unchecked for so long that it's become common knowledge in scientific communities as well, right?
Yeah,
so it's fascinating, and I think I would like to know. We should jump to your opinions on what are the dangers of this, right? Because I think there'll be a lot of opinions out there, myself included at one point when you sent me this information. And I was like, well, there might be an argument to be made for that. Hey, like, this is getting people engaged. This is getting people interested. This is getting people to rethink their relationship to nature and to wild things and to, you know, Mother Earth, if you want, or whatever, right?
Yeah.
And this is all good things. And I would agree. Those are all incredible things that we need more of. We need more voices and more skepticism and more, all that, right?
Yeah.
More love, more all that stuff. What would you say to that kind of argument? Like, cause I think it's an exciting thing to do, right? Like you just know, you're like, this feels right. It feels right. So therefore it must be right.
And I probably right there, I was like, if it makes you really mad or if it makes you really happy, pause.
Right.
Pause, because that's, you know, and it's not that listening to emotions is a terrible thing. They're there.
It's
they
crucial
serve
thing.
a purpose.
You need to listen to it. Yeah.
You do. Like they're not something to be ignored. But the world, out there also knows how to manipulate people's emotions in a way to make them do something, or, you know, to
i.e. any politician ever.
Yes, right. So it can be used against us.
And or a documentary, I should say.
Yes. So I'd be careful. But actually, okay. But what I would say though is the problem. So I agree 100% that I think that many of us need to rethink our connections with nature, rethink how we interact with forests. And, you know, and there's always good discussions about how we manage nature, how we manage forests. These are all discussions I would not ever want to see paused.
No, of course.
But the problem though with this situation is if we let the science be distorted in a situation where we like where it goes. So in this case, we like the idea of cooperation. We like the idea of altruism. We like the idea of trees in families and taking care of their babies. We like all those ideas. And so if we're willing to let the science be distorted in that situation, what's going to happen when someone comes along and distorts the science in a way that we don't like where it goes? Say if someone comes along and paints the forest as like, it has no value. Here is my evidence.
Right. Yeah.
Right.
Right.
And then, I mean, I can guarantee there's going to be a lot of people that would step up and like, no, let me scrutinize your evidence because they don't like where it's going.
Right.
And I would say that's a problem because distortion is distortion. Whether you like where it goes or where you don't like it goes, it needs to be called out. If we don't, then what is the point of my career? What is the point of scientists? Like,
right.
it erodes the entire scientific enterprise if we are not calling out bias when we see it.
Yeah.
Whether we like it or not, it is our job to be able to look at that and be like, okay, we need to scrutinize the evidence because I agree. Like, I mean, yeah, I grew up in forests. I love forests. Like, there's nothing in me that wants to see them like damaged or removed from the planet.
Right.
But at the same time, to be making those choices and decisions, we need the best science possible. And distortion of science is not the best science possible.
Isn't it ridiculous that you have to say that? You're like, hey, by the way, I don't want to turn the forest into a parking lot. Like, it's like, well, yeah, I know you dedicated your entire life to mycorrhizal networks and understanding the ecology of them. And like, it's funny how we have to say that because it's just, you're like, okay, where's this person coming from? Because I think it would be super easy for someone to look at this conversation and
see an agenda,
see that like, okay, who's funding this? Who's doing this? Who's doing that?
Yeah.
And like, I think it's important also to point out, like,
and for your listeners, I should point out there's no exterior funding.
Right.
So for Melanie, Jason, and I, we have our salaries from our respective universities, but that's it.
I think it's always fun when people are like, but the university gets money from this company. And you're like, yeah, but that's a different.
You can, yes. I mean, you can
always
attach
tie those dots if you want. Yeah.
Like you can follow that thread. Sure.
Conspiracies are fun.
Yeah. But I mean, just, I guess the optics are, you know, if
look
people
at the work,
need,
right? Like, look at the work. The science is there.
Yeah.
You're just pointing out something that you're like, hey, and I think it's important to point out something you said to me in an email was, like, this doesn't mean that that these statements may yet turn out to be true.
Yes.
You're not saying that like this isn't happening. You're just saying we don't know that this is happening. Let's be cautious about jumping to conclusions.
Let's put the brakes on. Like, it's the kind of thing, it's like, you know, there might be life in outer space, right? It's
Statistics
totally possible.
would say that there probably is. Yeah.
It's totally possible.
Or probability, I should say.
Yeah, but we don't teach it or talk about it to the public as if it's an established fact. Right? We use very careful language about that to convey the uncertainty, what we know, what we don't know, why it might be probable, why it might not be. We use a lot of language. So it's very clear that it's possible, but here's where we are.
Yeah.
The example from the Wood Wide Web, there is very little guardrails that have been put up. And so now there is a lot of confusion and, in my opinion, misinformation on common mycorrhizal networks and forests, that the possibility versus established fact is totally blurry.
Yeah. And I think like, if it did turn out to be true, if it did turn out to be that these I can't say that word.
I know. I think I messed it up
I try spelling it. Like every time I go to spell that, I'm like, where's the H? Is there two R's,
yes,
two C's? It's a terrible word. But the common mycorrhizal networks, imagine they turn out to be, it's all interconnected and they're all interchanging and they're all cooperating and the fungus is somehow benevolent and creating this, utopia of reality.
But we already know it doesn't work like that.
But we know it does. Yeah. Like that's not, I think it's like communication and talking is a big thing to say, right? Like they're communicating and trading resources and it portrays a certain picture to people, right? And of this, like this difference of the way of what reality is. And my thought was always, well, the fungus is just doing what's best for the fungus. It could give two shits what the trees it's connected to are doing unless it's helpful. If those trees, and that's kind of all, I don't know if that's true. That's not a scientific statement. That's a personal statement of mine. But like, it just it was confounding to my idea of how things evolved. And I always thought it was odd. And so it was interesting. When I first reached out to you, I just want to talk about these cool things, these cool mycorrhizal networks. They're awesome.
Very cool. Yeah.
And I just wanted to ask you, like, hey, I've heard about this. What is this? Tell me about it. It's cool. And you're like, well, yeah.
Sorry, Matt.
Like I have to burst your bubble. And I was like, shit.
Yeah. I know. And honestly, like, I can't tell you how many days I wake up and it's just like, oh, I just killed Christmas for that person. Right. Oh, I just killed Christmas for that person. Like, it is. I don't have a lot to gain in this story. Like,
you're going to be painted out to be the bad guy, I'm sure.
Oh yeah. Like there's, as far as I can tell, it's mostly been things I've lost in this situation. But like what is most important to me though is protecting the credibility of the scientific enterprise. And that goes way beyond me and it's helpful for all scientists. And
what's true is what's true.
Yeah.
Like it's just, it is.
Yeah.
And
So yeah, but like definitely, like I said, yeah, most days I just feel like, I'm killing Christmas for people. But and I can't impose like how I feel on other people. But I guess for me, I'd rather know the truth than believe in a fairy tale when it comes to forests and how they function. That's me though.
Yeah.
And so I'm imagining other people are like that and treating them like how I would want to be treated. But for sure, there's probably people that don't want to know. But the other thing in this conversation though, it's like, just because we don't know very much about the function of common mycorrhizal networks in forests, it doesn't devalue cooperation. It doesn't devalue different kinds of species interactions, symbiosis. It doesn't devalue these questions about can non-animals communicate in ways that we don't quite understand. I have nothing to say about those conversations in terms of like, I think they're great conversations to have, and I actually have nothing to add to them. All I'm adding in this situation is just to say, in some cases, the evidence that you're using to support these claims, it's actually not there.
Right.
And it doesn't mean that none of this doesn't exist.
Right.
It just means that this piece that you have been relying on to make your story, it's not as solid as you think.
Right.
And that's my only purpose in all of this. So, because the other thing I notice is, it's like sometimes people get upset or defensive about, cooperation and facilitation. We all know that it exists. Yes.
Yeah.
I have no arguments. We've known that for a long time. And this doesn't take away from that. So, yeah.
Yeah. It's tough, right? Cause like you're in this position where you're like, how do it's funny that now I imagine you're spending more time defending why you've did this study than you are actually, and like what it comes down to, than actually saying, you know what I mean? Like you have to defend your reasons for it. Like I imagine it's more personal attack than it is, like it's unfortunate, but
yeah, in some cases, and it's kind of confusing because in a way when, so for example, COVID misinformation, and there were a lot of situations where people who were totally not experts about COVID were asking questions, sowing seeds of doubt mongering. And the public picks up on this. And now that, many people are afraid of vaccines or whatever. And so as an antidote to that, we expect that experts in that field are upholding a high bar of scrutiny.
Right.
So that when others like me, I'm not a COVID expert, but if I can trust that field to know that the researchers there, they're holding themselves to a high bar, that whatever is coming out of that field, I can trust.
Right.
And so this idea, when you're a non-expert and you're coming in and like asking all these questions, doubt mongering, most of us don't like that because we're like, you are not an expert in this field. Right. Sit down, stay in your lane. I want to hear what the expert has to say.
Right.
Right.
Yeah.
And so that means then we're trusting experts in the field.
You have
to be calling out, no, that's misinformation. No, that's in dispute. That seems like an extraordinary claim. Can you show us some evidence for that? We are trusting the people in the field to be those people. And so I am one of the people in the field of common mycorrhizal networks and forests.
Yeah.
And so I can't imagine, like, who else should be calling this out then? Like, if it's considered, if someone says, oh, it's like I have an axe to grind or whatever, and I don't even know what to say. It's like, who should be calling this out then? If you don't trust me, or if I'm not the right person, an expert in the field that could, with some authority, say, hey, there's some problems there. There's some confounding effects. Then who do you trust to be calling this out? Who do you trust to be upholding our field if you're not trusting the people who actually are researching for the past 20 some years in the field?
Yeah.
And so that part I find very confusing. And I don't know what to do with those comments, and just like, I just think,
I don't think there's anything you can do. Like, what can you do really? Like, you're not going to sit down and explain, and teach them everything they need to know from high school all the way up to a doctorate to understand this concept. It's because you can't do that, right?
Yeah.
So it's like, you just at some point you have to trust experts. Like, you've spent your lifetime doing this. You're like, and not necessarily trust you personally, but you can trust the science, or scrutinize the science at the very least. And well, you want to know, it's like, skeptic has such a dirty connotation to it now. Sure.
Being a skeptic, there's just all these stereotypes and stuff, but it's like science relies on it. And it's very easy to be singing lullabies to the public about common mycorrhizal networks and forests.
Lullabies.
Here's all the fantastic things they do.
Like. Yeah.
It feels good. People love it. It makes them care.
Yeah.
But that's not my job. And my job as a scientist is to be critical, to be kind. I don't want to be I really try not to be mean and mean-spirited when I am saying, hey, there's some problems, or I don't understand this. This seems inflated. And
you should be able to do that in science. That's what science is for.
Yeah. But it just feels like it's harder and harder to do that. And I guess for me, the other goal with this study, so to shine a light on the misinformation out there, but the other really important goal is to reset the research field. And so part of this study, so we identify some problems, but we spend a lot of time identifying how we can go forward. Here are the experiments we need to do. We're not talking about new technology. It's just, it's packaging them in different ways so we can eliminate or account for confounding effects. So we can test what we think we should be testing.
Let's figure out what is going on. Yeah.
And so we're really excited about Common Mycorrhizal Network 2.0 in forests.
Right.
There is a lot of possibility. There's a lot of potential. There's some great experiments out there, and we're really excited about that.
Yeah.
And that's what we want to see.
Yeah. At the very least, we know that carbon is being transferred between, that in and of itself is crazy. That's not untrue. That is happening.
Exactly.
But why and for what reason? And
how?
How much and how impactful? Those are all answers that we don't have.
Yeah. So I'm still excited about the field. I'm still excited about where it's going. But I really hope with this paper that it does cause people to pause and look back and okay, maybe the evidence wasn't as strong, and like, oh, we've got this problem in the scientific literature that there is a positive bias that paints a picture of trees benefiting by these common mycorrhizal networks. Like, those are problems. To me, we have to get our house in order and be open to it and admit it and move on.
Yeah.
And different fields have had their problems, like psychology, that the replication crisis. Like, different fields have had similar problems. I guess for me, I was surprised that it landed right on my feet.
Like, wait, I'm the person that has to do this?
Like, what? No. And, and that's the other thing, Matt. It's like, when I talk about, I have nothing to gain by this, because that's the other thing. For the past year and a half, like, this was not a study that we worked on, a few hours on the weekends. Like, this has been like us immersed and consumed by this, putting together the evidence, looking at the studies for the past year and a half, going through all the like popular media. That is all time that I could have spent working on new experiments and, or doing something that is a positive addition, something new to the field.
Yeah.
And I do think this kind of consolidation is very, very important.
Totally.
But yeah, this is a year and a half, and
I think I think this is probably the most impactful. It's got to be one of the most impactful studies you will have done in your career.
Oh yeah, like right?
This is a big deal, and it's something you should be proud of. Like it's just like, I understand what you're saying though, because it sucks to have to be the person to be like, hey guys, I found some problems with our homework.
Just like the total wet blanket buzzkill.
Yeah.
No, and I mean, I'm excited again for the reset that I hope will happen. Like, we have a new direction to go with our research. Here are some issues. Let's move forward. Let's be very careful with the claims we're making, because many of them are not supported.
Yeah.
But I'm also terrified of like just dumb things. It's like, I imagine going into a conference and like getting booed or something. Just,
right.
This is my colleague's work. And so all of that is,
yeah. That's hard. Like, 'cause you definitely, from the outside looking in, it seems like you're sacrificing a lot here to try and stand up for the science, the way the science shows itself. Right. And that you're definitely putting your, I don't know, I wouldn't say your personal well-being, but like maybe
I'm putting my reputation and my name.
Yeah.
Right. And like, this is my name. This is what I've signed to. This is what I said is going on. Like, that means so much to me.
Yeah.
And, and I'm putting it on the line as to like, there are some problems.
Yeah.
I should say though, we haven't been totally alone. So yeah, you mentioned I'm on Twitter, and we've had a lot of cheerleaders. Or sometimes, I'll get like kind of the rare email of someone that I don't know and just like saying, I'm really glad you're doing this. And I had no idea, and just glad someone's looking into that.
Yeah.
Not very many. But that has been really good and helpful. And at the same time, I mean, people ask us questions on Twitter. Yeah. Sometimes they criticize us. It's all been very helpful in thinking very deeply about what's going on. And so, in some ways, it's just the three of us, me, Melanie, and Jason. But throughout this year and a half, there has been interactions to the wider community to let them know, like, as soon as we saw some stuff going on that's like, oh, this doesn't look good. We started like, letting that out of just like, no, actually these studies don't show that, or we actually don't have any studies supporting this claim, and letting people know that, okay, there's some issues here.
Well, there's an industry building up around this idea too, right? And you're like, okay, based off what exactly, and what are we pushing for, and what's the end goal here? And like, I don't think a lot of researchers would have done what you did.
I don't know.
Like, it seems like a big risk, right? But like, ultimately it shouldn't be. Ultimately, if you were just looking at the objective truth, or just looking at the facts, don't even say the truth. We'll just say looking at the facts of what we know, what can we definitively conclude from these facts? And it seems like you've just kind of laid that out, is all you've done. You haven't really said, like, you know what I mean? You're just like, hey, this is what we can. Yep. This is what we do know, and let's start from here and figure it out. But let's not jump to conclusions and go crazy here before don't put the cart before the horse.
Yeah. It just, I guess it's like, because we know how much of the public love this story. Yeah.
I love it too. Like like I said, I had a connection to it as well. I'm like, man, that's crazy. If competition isn't a thing, then what? That upends everything, which would be incredible.
Yeah.
And who knows? Maybe it is still true. We don't know. But it's just like, I
like, it just puts you, like, in my position immediately at odds with so many people.
Oh, of course.
Yeah. And so that part is, like, most of my research up to date has never been combative. It's never been, like, really challenging.
Yeah.
You know, it's like just adding little experiments here and there to the knowledge base.
Right.
And, you know, in looking back, like, I just appreciate scientists so much. They're just chipping away at hard problems.
Right.
Chip, chip, chip. And they're not succumbing to this immense pressure we have to hype, to oversell our results, to exaggerate, to get papers published, to get grants, to get clicks. It's immense pressure. And I don't want to dismiss it and like color it as like, if you fall to that pressure, you know, you're a bad person. It's nothing like that, because it's intense.
We need good science communication that brings the emotion in to get people involved.
We
for
need
sure.
all of that.
But not in the scientific literature.
No. Yeah. And it's just, so when I think about, you know, those are my heroes to me. It's just those scientists, again, just chipping away at hard problems.
Right,
They know they're adding to like a foundation, and the foundation is so important.
Yeah.
Like you want, yes. So for example, that Nature paper we started the conversation with, disruptive. We want some of those disruptive,
right?
Like show us a different way of thinking. Oh, we didn't realize that.
Yeah.
Wow, this is so new. But only if we have like a solid foundation. If there's no foundation, you don't even know if it's disruptive.
Yeah, right. Like,
you need that foundation. And so now after all of this, I will very happily go back to like chipping away at hard problems and leave it at that, and just be very happy with that contribution.
Yeah.
Yeah.
So I guess to speak to the due diligence piece, what were the peer review process for this study? What were the comments like? Like how much? Because I'm imagining like, okay, you're down the line, and then someone else comes out with a paper being like, Justine's an idiot. Like this is what actually this says. Like she missed this, this, and this, and this. And like, we have to speak to that as well, right?
Yeah.
Like,
no, that's like, a good,
So what kind of feedback did you get from your peers regarding this? And, like, I mean, the objective feedback, right?
So it went out to 4 reviewers. 3 of them signed their reviews. So these are all, you know, eminent, mycorrhizal ecologists in our field. Uh-huh. And that was, to me, that was really reaffirming that they would sign their reviews in that way.
You did your homework and
And to me, it also indicated that they were willing to put their name on it in terms of like, very constructive comments. And I got the sense it was like, we need to make sure that you, Jason, Melanie, got this right. And so
if you're gonna make this claim, we have to make sure it's true.
Like we got to make sure this is done right.
Yeah.
And so that there isn't that follow-up paper like, oh, Karst et al., they missed this and blah, blah, blah. Right. And so very thorough, constructive comments. As I mentioned, you know, they said go back and look at the lab studies.
Yeah.
And, you know, so that was really helpful, helping us like tighten our arguments, understand when we were on, you know, thin ice, and being very clear about that.
Right.
And then also being very forward thinking. So it didn't come across, you know, and we try to be very clear. This is not an attack. This is like us trying to reset the research community in terms of what we need from these experiments and the questions we can address and we can't with what's there.
Yeah.
And so they helped us with that. But it was generally there was no negative reviews, among the 4. And of course, you know, I mean, maybe a little bit atypical, like the response letter was like double the length of the actual paper just to like go through everything and like make sure. Yeah. And it's, you know, just like all the numbers and stuff, like how many times we've checked them, like with the citation analysis, there's an appendix that is over 100 pages that we pulled out each of the statements that we thought were unsupported and explain why. And it's like thousands of these.
Yeah.
But so then someone could go find like, oh, Karst said that I made an inaccurate statement. What did she, so they can go back and they can see this is why they thought the statement I made was unsupported. And there's text right there. We wanted to be 100% transparent about that because it is a little bit subjective.
Yeah, totally.
So there's that. So obviously everything was checked a lot in terms of like the claims, the papers.
Mm-hmm.
Like it was also a lesson in how much I need to be more careful in how I read papers when I'm citing them for something. Like it was a lesson to me. It's like, I need to be more careful and I can't just be a little parrot. Here's what the study found. And then I report that, because if I don't engage with it, like how we did with those original studies, the field studies, you can report the conclusions and you can say as much, like, here's what they reported, and kind of buys you a little bit of space,
I remember writing reports during my bachelor's, and you're just looking for, this study says this. Yeah. Take that quote, throw it in. I'm good.
Done,
Didn't read the study, just like took this little piece and these people said I did it right.
Yeah. It fits my argument.
Yeah.
But that's not what our job as scientists is. Right. It's to critically engage, and you look at the conclusions. Do I buy those conclusions? And I need to do a better job of that. That was one take-home lesson I learned, is and teach my students how to do that. Just because they conclude so-and-so doesn't mean you necessarily conclude so-and-so. Right, you need to go and assess the results and how they got them to maybe there's some other interpretations.
Yeah.
And that's how science moves forward. It does not move forward when we're just being parrots. It does not work.
Yeah. No, that totally makes sense. I was listening to a podcast, and this woman said, and I'll just keep her name out of it simply because I don't know if she wants to be associated with this.
Sure. Yeah. That's fair.
She was bringing up there's like 4 pillars of understanding, right? So there's intellect, which is like the science, the intellect and measurement. That's the science portion, the Western science, right? Mm-hmm. And there's also the mind, body, and the spiritual way of knowing, right?
Yeah.
And I think the science is those first 2, right? It's the intellect and the measurement. It's the physical world and thinking about the physical world and what can we measure, what can we prove, we need that. And we also need the mind, body ways of knowing, and the spiritual ways of knowing, and the belief system ways of knowing, in order to emotionally engage with the world and
identify our values.
Exactly. Identify our values, which helps push the intellect in another direction, right? However, I think it seems like we've gotten to a place where maybe these 4 are starting to turn into 1, and you start to lose objectivity, or maybe not objectivity. We start to lose, where is this information coming from, right? Is this an opinion, or is this a fact? And where we you look at the media, and they have to, I think there's certain places where they have to say, this is like in the newspaper, this is an opinion piece, right? Yeah. And I think we need all of those ways of knowing, and we need the emotional connection, and we need the intellect, and we need the measurement, and we need that spiritual connection, but we have to be aware of which one we're talking about.
Yeah.
And they do all interconnect.
They do. Yeah.
But they shouldn't be,
blended. The other thing too, it's like science has to recognize when it's not invited.
Yeah.
Right?
Right. Totally.
And, we're talking about values, and, even with forest management, there's different values out there. And it doesn't matter how much science you bring into it, because it's a clash of values.
Yes.
And so that's the case. It's like, it's recognizing, but it's also, when you're there in that clash, it's also acknowledging, like, this is a value I hold, and it's different than yours.
Yeah.
And I think this is what's causing the problem, because it doesn't matter to me how much data you bring to the table. This is a value. And so if you're going to change my mind, you're talking about me shifting gears in my values. Maybe not impossible, but it's an example of, like, science, you're not invited. And it's just like, for scientists, there's some spaces that we don't need to be putting our noses in there, because it's not appropriate.
Right.
It's not appropriate using science to attack values.
Yes.
So I wish it'd be helpful in those discussions if people could be more articulate, or recognize, or have the awareness when they're in a value territory versus an evidence territory. And I think that actually would be like really helpful in a lot of conversations, because you just end up talking over each other, and it's like, why don't they believe my data? Why isn't this convincing them?
It's not about the data.
It's not about the data. And so park it.
Yeah.
Yeah.
I think those are conversations that even on this show, I've had multiple times, had whole episodes with panels, like 3 or 4 people talking about forest values and how do we manage this? And how do those things apply to doing forest management? Because, up until now, we've basically, you can just say it as simply as we've valued timber over everything else, right? And we've made sure to identify the other values and use those other values as constraints so that we don't wreck them with our timber acquisition. And we're like, yeah, that's good. But now we're getting to the place where it's like, well, maybe these values are co-values and they need to be intermatched. I think everybody in industry and environmental community are thinking that way. And we're just trying to figure out how do we go about this, right?
Yeah.
But I think now is a good time because we're starting to recognize that we can have scientific and spiritual, emotional discussions at the same table, as long as we're not,
as long as they're not mistaken for one another.
Exactly. Right.
It's like, okay, we're talking about values. We're not talking about evidence.
Yes.
And it's also being careful of like not to delegitimize the values over science.
Totally.
Or in some cases,
values are totally subjective.
Yeah. Or in some cases, maybe there is a place like, okay, we need to park the values and we actually need to focus on the evidence for this. It's, because it's a difference between like positive and normative questions. Like positive, it's where science is. How much does a tree grow? How much volume is there? What happens when we harvest? Those are all positive questions. The normative, though, like, do we want to harvest forests? Should we? What kinds of forests are we comfortable harvesting? Should we harvest old growth? All the shoulds, those are normative, and those are more, now we're getting into values.
Right. And it can be backed up. Those decisions on those values can be backed up by the positive, but
they can. Yeah. It's like there's still space, but that's what I mean. It's like, but as a scientist, I'm not going to come in and say, well, here's why you should not harvest or whatever, because it's totally missing this dimension of like, well, wait, it's not just about the numbers. It's about these other values that they need to be on the table as well.
That's that balance that we're talking. I think that's, again, that's why this Wood Wide Web thing grew so big, because we're in this transition period of like, creating ecological forestry and creating this place where we're thinking about all of the values at the table at the same time and creating some kind of, decision matrix on how to do this appropriately, right?
Yes. And I think though the Wood Wide Web and all the stories that go with it is an example of how science has been used to legitimize a value in a way that is inappropriate.
True. Good point.
Right? Because now it's like people, but there's evidence that trees are sending signals to each other. And it's like, well, actually there's not. Just at some point, it's just like, just admit you want trees to be cooperative. You want forests to be cooperative places. Okay. That's the image that you want.
But is it factual?
And you're drawing, and in this case, on misinformation to support this virtuous image of a forest that you want so badly to be because you think it's going to forward your agenda. And so to me, that's where it gets very messy. And
if we like what you said, your statement about holding up the integrity of like the scientific process, or however I forget how you worded it, but without that, like already we have people, like you said, COVID's an excellent example of people questioning science and people questioning experts and studies. And it's like, okay, if you don't trust this, what the hell do you trust? Grandma?
Yeah.
Grandma doesn't know what the hell she's talking about. She knows how to bake good buns. That's about it. So it's like, let's talk about this. Like, why don't you want to trust the experts? And like,
But Matt, so then it gets more complicated though.
True.
Because so for the Wood Wide Web, our experts, there's bias in our scientific literature.
Oh, totally. Yeah.
Right. And so so now it's like, I don't know. And then that's what I mean. It's like, it's easy to be like, oh, this person who's not an expert is going off about this story, like easy to dismiss. But these are scientists in the field that are like, you know, part of the vectors of, and again, it could be totally not, you know, not intentional. I don't know. I can't get into their minds. All I can see is the outcome of it. And just like, okay, we have a problem. This is a rot in science. And so that's the part that is, you know, I mean, we all know that science it's not infallible or anything, like we know, because it's done by humans.
Yeah, of course
we all know
not.
it's imperfect. There's these ideals.
You totally destroy old ideas by new discoveries constantly. Like it's constantly evolving. Yeah.
And so, but the problem here though is that we can't in any defensible way point to the non-experts as the problem.
No.
In the Wide Web, right? It's like holding a mirror up to ourselves and being like, ugh.
Whoops.
And that part, it weighs heavy on me.
Totally.
I very much wish that like the second part of the study showed something else, right? Like this is my bias. I want to like, you know, for science to be pure, to be perfect, to be objective. And this is a clear case that it's not.
Yeah.
And so it's just so messy and I'm not sure yet how to move forward out of that. I mean, in the paper, we gave some suggestions on how to cite, good citing practices. We suggested that, you know, we should move away from anthropomorphism. You know, it's not helping. We gave some, you know, some suggestions about science communication, but it is like, it feels more than that though.
Yep.
Like it's, yeah. I don't know. Yeah, I don't know what to do about that part. There's honestly some days that I'm like, I'm tapping out. I'm done.
Totally.
Like I don't want to be part of this anymore.
Yeah.
I'm sorry for the part that I've played already. And I'm trying to do what I can to fix it. But like, I don't want to be part of it. And so there's definitely some days that I'm just like, you know what? I'm just going to focus on teaching. And I'm just going to let the research go because I don't want to be part of it anymore about the hype and the pressure, the clickbait, all of it. I don't want to be part of it. But then, so for example, Melanie, my co-author, and her husband, Dan, you know, they know that I've been really struggling with that and they've always been really good. They're like, anytime you have that thought, you call us.
Yeah.
You know, and I've called them at least once, like, I'm having that thought. I don't know if I can keep doing this. And then they'll, you know, give me a little pep talk and get me excited about research again. And so on I go for a little while, but,
That's so hard.
But it's hard to express the weight, the burden that this has been. So yes, it's killed a lot of my joy and what I thought was. And like, it doesn't feel good to put a paper out like this. Like it does not feel good. I wish I was putting out a paper in some high prestigious journal that was like, look at this exciting new research. I have like this new discovery about mycorrhizal fungi. Like I wish it was like that.
Yes.
But it's not. It's the total opposite. And yeah.
But it's like as a human being, like as a person who has emotions and has values and has those things, like I can't even begin to imagine how disruptive and, like you said, like grief makes sense. Like grieving this process and grieving what happened and grieving these ideas. And but I think this is all good. Like this is all
so.
Like it's not good to keep science moving off of a lie, right? I shouldn't say a lie. That's the wrong way to say it.
Yeah.
Off of a misinterpretation or misunderstanding, right?
Overinterpretation.
Because everybody doing this, everybody involved in this concept and pushing this concept is coming from a place of good. They're coming from a place of, look at how awesome this is. This is so cool. I'm so excited that we're learning these incredible things. This is all good intentions. But it's unfortunate that you and your colleagues had to be the ones to, you know,
hit the brakes
on everything. But it was inevitable. It was coming, or we were heading to a place where nobody trusts science anymore at all.
I know, yeah.
So it's like, what is the option, right? Like, it's like, okay, can we trust science? And like, this is one way. I have people in my life that have come up, in the last 2 years and been like, you can't trust the science. And I'm just like, I can't even, you're like, sometimes you're right.
I know.
Sometimes you're right. Like, cause there's issues. It's not infallible. Right. And this is a win for science, I think. Right. Like, this is a win being like, listen, hey, we'll see how the public and how, not the public, we'll see how the scientific community responds to this and how it comes out. But I think there's going to be all kinds of emotions, I would assume, all kinds of, feedback and critical feedback and good and bad. But I think ultimately in the end, we need to know the truth. And let's not get carried away with ourselves. And,
and that's like when it all came down to it, when we started seeing the results and the lack of evidence for these claims, we kind of talked for a while. We're like, should we say anything? Like,
right.
It's going to piss off so many people. And then finally, it was so uncomfortable. Like, we just knew how uncomfortable it was going to be in this position. And then, we talked about it. And then finally we're like, we have a professional obligation to call this out. It does not matter how sad we are or how uncomfortable we are. Like, we have a professional obligation. This is our duty. And I think once we accepted that, then it was, we could still feel everything we were feeling, but that's what kept us moving forward.
Yeah.
We have a professional obligation to let the public know. We have a professional obligation to let our research community know that we're seeing some problems. And so it was just that sense of duty, honestly, that like,
it's funny though. You have to separate yourself from the humanity of it and just like, how do we be objective?
Yeah.
How do we make sure that we're on track here and we're not off in the weeds somewhere looking for something that doesn't exist or may not exist, right? Like it's, like what is your hope for the response to this? What do you say 20 years from now? Right? You're retired. You're on some beach somewhere kicking it. And, what is your hope for the response of this study and how it changes things?
I hope that it does inspire people to get back to doing experiments. Like I said, there hasn't been that many new experiments that have come out recently. Most of them are for 10 years ago or whatever.
Yeah. So
I'm really optimistic that it inspires people to try some new field experiments, mindful of the issues and limitations of the past experiments and, deal with that and start a new avenue of inquiry. So on the science side, I'm very hopeful about that. I'm also hopeful or like these ideas, they have extended all over the place, like into other disciplines and in a way, that's amazing and fascinating how these ideas, the Wood Wide Web has spilled over into all these different places. But I hope that it also reminds people and challenges them to there was only a few voices involved in the story. And it's very important to get that wider look of what does the field say? I guess on that note too, I really hope in the future experiments, a lot of different labs tackle these questions. I think that's really important and really necessary that we get a lot of different perspectives, a lot of different ideas, a lot of different forests that are tested.
Worldwide, preferably. If we're going to talk about it being worldwide, then let's do worldwide. Yeah.
So that's what I hope. But in these other disciplines that have really leaned heavy on this idea of the Wood Wide Web to reset society or think about how we interact with the others and, using nature as their model, I hope it gives them pause. And then I hope it also reminds people it's like, we don't need to go to this template. We can decide how we want to interact with each other. And that there is some limitations and danger to be using these templates of what we think nature works like to decide how we want to live.
Yeah.
So that's, and then I guess very broadly speaking, that I really hope, with the public, there's going to be a lot of like, oh, so what do we believe now? We thought this was like, well-established facts, and now it's not.
Now you can't trust science, yeah.
What are these scientists that don't know what they're talking about? So there's definitely going to be a lot of that, I think, in the short term. But I'm hoping the long term, though, that doing stuff like this, and it's not just our field, it's other fields that are having to do it too, that it rebuilds that confidence with the public of like, no, science, it's not the only tool, but it's a good tool to understand our world. There's lots of promise in it. Yes, it's subject to perils sometimes, and like,
don't blindly follow it, but be skeptical for sure.
Yes. But there is this self-correction mechanism. It is present. Sometimes it takes a while to kick in. But it is there. Yeah. Yeah.
Man, what a conversation. I was so nervous going into this conversation. I was like, I don't know how to do this. I'm glad you do. You obviously have spent like, watching or reading the article you sent me and the seminar, and like it was very evident that I can't imagine anybody telling this story more.
The only other, Jason and Melanie.
Right, sure.
Jason and Melanie are the two others.
You've obviously thought about all the aspects, and I feel like you've considered as much as you possibly could and provided a good perspective. And I think it's hard to deny that this is coming from, you know what I mean? Like, you're just like,
no, I'm not flippant about it.
Yeah.
And it's not a superficial little scratch of what's going on.
Yeah. You obviously care, and this is obviously, yeah, exactly. And that comes out in the way you talk, in the way you present the evidence, in the way you are careful about, misrepresenting this as well. Like, you know what I mean? You can see yourself thinking about, okay, not that word, this word, like that.
Yeah. No, the precision in language, that's another, it really matters. So, and there's probably a few times in this interview that I did mess up some stuff. But
you're only human. I said a couple of stupid things, I'm sure.
Yeah. So, yeah.
No, but it's incredible. And I hope that there's not as much doom in your, Twitter future as I suspect there might be. I hope that, with time, this is, taken up as a positive thing, and like, okay, now we have a chance to really figure this out, and who knows what incredible things will come out about these common mycorrhizal networks that we don't know yet, and what might be proven true. But in the meantime, let's
here's what we know right now. Here's where the uncertainty is.
Yeah.
Let's stick with that.
Yeah.
And honestly, Matt, I mean, what happens to Twitter is one thing, but like I said, my goal after this is like to go back in the forest, do little experiments, trying to figure out how things work. I think you've got a speaking tour ahead of you, I suspect. I suspect you're going to get some phone calls. Oh, I
don't think you can hide from this one.
Maybe not. I don't know. I certainly have no plans of anything like that. Melanie and I, we have a field experiment planned for this summer. Of all this, the one little glimmer of resource transfer was actually water transfer. There was one study that had a very convincing data point that water was moving from a tree to a seedling through a fungal network.
Interesting.
It was just one root tip on one seedling.
Yeah.
But it was the strongest evidence we saw.
That's all you need to start looking, right?
And that's exactly it. So we want to follow up on that.
Yeah.
Like, what's going on there? Is it something? Is there enough water moved around that it could actually affect a seedling? I don't know, but this
is not a very scientific question, but are you hopeful that these common mycorrhizal networks will turn out to be a really big deal and very cool to think about?
I am not somebody that hinges my hope on any one part of the ecosystem. I love mycorrhizal fungi. I think they're very cool, the symbiosis, everything. But I've never been convinced that you can look at one piece of the forest and say that's the magic. Everything hinges on that thing.
Right. That seems pretty simplistic. Yeah.
Yeah. Like I'm not.
Well, I think even the forest industry has done that with trees.
Yes.
Right.
Yes.
Like we've done that with trees. Like we manage for the trees, everything else will follow. And that's probably flawed.
Yeah. But I mean, at the other extreme, I'm not. The forest is a superorganism. I do not fall into that camp at all.
Right.
But it is all these interactions, you know, and the complexity of the interactions that like, you know, holds this forest together. And that, so yeah, when we're managing forests, like, so yeah, you don't just manage for the trees. You certainly don't manage just for the common mycorrhizal networks.
Right.
It's thinking about like the forest.
Yeah, you don't want to trade one mistake for another one.
Exactly. Exactly.
Let's think about the whole. Let's try not to focus too much on one value, one aspect, because clearly, as we can tell, there's a lot going on out there, and it's all interconnected, and
and all that, it still holds. And I think it's and it's hard to get your head around it, and of course it's hard to manage for all of that, but it's also just like with some humility and, you know, just being modest about what we know, and just recognizing like there's some limits, and we might not get it all figured out, but we're going to try. And this is how we're going to try. In 10 years, we might look at now and like, oh boy, what were we doing?
Right.
Like this is just normal stuff.
Just a reset. Yeah.
And I guess what makes the stakes higher though, is because of things like climate change, where now we are really pushing our forests to like do a lot for us. You know, we want them to do a lot. And so, and if we're losing forests, so there's much more at stake.
Yeah.
Like we don't, you know, that time, like things are changing. So it does change a little bit, but no, so in my mind, like, and I think the other thing too, after doing this study is like, there's just lots of interesting things going on.
Yeah.
Independent of these mycorrhizal networks.
Yeah.
And, so I guess in a way, I've kind of stepped back from them. I don't have the same enthusiasm as I did 20 years ago when I first read that paper. But it's because I have a broader enthusiasm for just the whole forest now.
I love that.
Yeah.
Yeah. That's cool.
Yeah.
That's cool.
Yeah.
That's a perspective that I think I got into forestry because I like the forest. I like the trees. I like the forest. Just period, right? Everything in it. And now I've realized that I probably should have went into like an ecology major or something. Because what I like is like the interconnected concepts, and I think that's evident if you listen to the episodes in this show. It's evident that way. So, this is an incredible conversation. Is there anything you want to say to put the exclamation point, or just because I think feels like you've covered it all? Yeah,
I was like, no, I think I left it all on the table there. I think it's good.
Awesome. Well, thanks for your vulnerability and for the honesty and for the like. Clearly, you're putting your heart on your sleeve here, as well as your mind and all your intellectual power, right? And I think that will come out in the maybe the emotion will come across in the paper, but obviously in the articles that are going to come out and that have come out in this show and everything else. And I think it's going to go well.
Thanks, Matt.
I'm not saying there's not going to be hate. I'm just saying in the end, it'll be seen as a good thing. So thanks again for coming on. This is awesome.
Thank you very much.
Man, that was something, wasn't it? I mean, what are we supposed to... I don't know. That was incredible. I just have to say thanks to Justine for coming on and, you know, putting her heart on her sleeve and putting the science first and doing what I believe to be the right thing, kind of unequivocally. And, I hope that this does exactly what you hoped it would do, and that it resets the scientific community, resets the field, and we can learn and get excited about how nature actually works. And who knows what we'll find. But like you said, let's keep it to the facts. So thanks for listening. I hope you enjoyed that. If you like this episode, please rate and review on Spotify or iTunes or wherever you are. Share it on social media. I know it's going to get a lot of attention elsewhere. I know Justine's been dealing with some stuff online, so that's always fun. And thanks a lot for listening. Catch you next time.